the Chapter 10 extra practice on page 914. Everybody has problems like these next ones that illustrate one of your theorems that we've not used a lot. So it's really important for you to get this. Okay, let's look at, let's see, number 26. Wow, that looks weird. It looks all spidery when I get it like that. Okay, number 26, which is a circle. And this is a diameter. And this chord is perpendicular. Okay, because this is a diameter, you learned that a line is a diameter if it perpendicularly bisects another chord. Because this is a diameter and it goes through this chord with a perpendicular, that means it also bisects it. And when it bisects it, it also bisects the chord. That's not all that important on this part. Yeah, it is too. Okay, because we have A, B, C, A, B, D, and this is C, and this is E. This is numbered funny, or lettered funny as the case may be. Okay, and since this is a perpendicular bisector, and then right here we know that this is 125 degrees, that means all the way around is 250. So 250 minus 360 from 360 is 110. So the remainder of this arc is 110. Now because this is the diameter and it crosses through the chord perpendicular, it bisects the chord and its arcs. And so that means that this arc, which is 110, you're asked to give AB. So that's going to be half of 110 or 55 degrees. Okay, number 27. There are problems like this on all of your tests. The big difference with the advanced test is it may have weird decimals and stuff on it. Okay, this is another theorem that you have to remember, and that it should be on your theorem list. It says that if a chord perpendicularly bisects another chord, then it's a diameter. And it says if a diameter is perpendicular to a chord, it bisects the chord and its arcs. Okay, and this is 135 degrees. So the whole thing all the way around here is 270, or another way of looking at it is this is 180. You're asked to give just AB. So this is A, B, C, and D. Even though we don't know that the diameter, we can tell that this is the diameter because it perpendicularly bisects this chord. Okay, so another way of looking at this is saying 180 minus 135, or you could say 270 from 360, which is just 90, and you subtract it, or you could say 180 minus 135, okay, and then 90 divided by 2, because this whole arc is 90, so half of it would be 45. Or if you did it the other way, it would be 180, because this is the diameter, minus 135, which is also 45. Okay, so looking at 28 and 29 and 30, let's see. In 28, you recognize, I'm not going to have to draw these because you're just going to look at them and think about it. It says, is AB the diameter? And because it perpendicularly bisects CD, it is the diameter. By the theorem that says if one chord is perpendicularly bisected by another chord, the first chord, or the second chord, first chord, if one chord perpendicularly bisects another chord, the first chord is a diameter. Okay, and in 29, they're illustrating the theorem that states that if two chords in the same circle or congruent circles are congruent, then their arcs are also congruent. And then number 30 is if two chords are the same distance from the center. You know they're the same distance because the perpendicular distance to each chord is the same. Then you know that the chords are congruent. Okay. All right, looking at some other kinds of problems on the next page. On page 915,